If you're joining us for the first time, and come along to Doc Clay's A-Level Chemistry. We've got heaps of resources for you for all of your A-Level revision. Today, you can come and join us if you go to drclays-alevelchemistry.com. You'll come to a site that looks like this, and you're welcome to come and click through to the required practical webinars. Here you'll find all of today's resources for the webinar. You'll find a link to the YouTube video so you can watch it in here, and you can also find the practical handbook, which we're going to have a look at with just a small section from, and 3 specific examples from the specimen papers that we've sent out, along with the OneNote resources. So this OneNote resources has got all of the information that we see for the quick question webinar, which have all been on practical elements of the course. If you're wanting to join up, please do so, and you'll also get access to all of the past webinars, which I'll show you. We've got heaps of past webinar information. We're looking here today, 5 uncertainty quick practical questions. That should say percentage uncertainty. I've just obviously missed a shift off. I'll change that at the end of the session. Click through there and you'll get to all of today's resources and the answers. We've also got all of our other webinars, which if you become a joined up member, you'll be able to access along with all of the resources. Again, for all of our members, we've got all of the course in our video content section, which you can sort of have a look through and see what's in there, etc. So we've got things like the video tutorials here, along with key concept questions. So I'll just go back here. Importantly, for today's session, if you want to join in the chat, I won't be able to pick up the chat from this window at the bottom right hand corner here. So we've got this chat window, which good afternoon all those who are online. I tend not to use that one during the webinars. I always use this blue chat box during the webinar so that I can see who's online. It also makes my life a bit easier. So if you're posting in the bottom right hand corner, please accept my apologies. Feel free to private message me if you wish through that, or email me, but I won't pick it up during the webinar. Okay, so we're nearly at 4:05 now. I'm just going to move this out of the way. Here we go. And just a quick sound check, and those in the room, can you hear me? If you can, please do respond so that I know that we're all working okay, and then we shall get down for the short webinar just on percentage uncertainty. Hello, and on. I can't, and on and on and on. I think that's a nice little joke there. Very good. All right, so let's start. We're now at 4:05. Like I say, if you've missed it, I know we normally have it on a Wednesday session. Today we're doing it early on the Tuesday. There won't be one tomorrow afternoon, but next Wednesday, as per normal, we'll be back for the practical revision session, where we'll look at those practicals that we haven't looked at so far. All right, now percentage uncertainty. It's an area of which has caused some confusion. All right, now all I'm going to start off with is the simple statement about how we measure percentage uncertainty, and this is the key thing that they're looking for in the exam, and it's simply a measure of any errors in your practical. So it's a measurement of the error in your practical divided by the measurement that you take and then multiplied by 100. So I'm fairly sure that we'll all be quite happy with the actual percentage uncertainty. There's nothing unusual or confusing about that equation, but where we are seeing some issue is how we identify what error value we need to use. And so that's the core part of this uh, webinar that we're going to look at this afternoon. And in order to do this, I'm just going to show you a couple of key documents. Now, the first is available. I put it on there for you to see, and it is called here, all right, simply the AQA Practical Handbook A-Level Chemistry. Now, if you put that into thanks. If you put AQA Practical Handbook A-Level Chemistry into a Google search, you will come up with a 152-page document. Okay, now I wouldn't encourage you to read the whole of this document, but this is a live document, so it gets updated reasonably frequently by AQA, and it details how to work out the uncertainties and also any of the other practical elements. It's perfectly available online, AQA Practical Handbook A-Level Chemistry. So feel free to Google it, that's not a problem. But the key points I've put available to you on the webinar page there under AQA Practical Handbook. And it's just printed out for you about 8 pages or so dealing with uncertainties. And from that document, and it covers all of the sciences, by the way, not just chemistry. These are the key points that we really need to be aware of for the A-Level Chemistry exam. And hopefully I'll be able to show to you as we do this where the slight curiosities appear in the specimen papers. So the first thing is that we've got 2 types of you can have. The first is a reading, and a reading is something like a single value. So this might be measuring the temperature. So the temperature at, let's say, 25 degrees Celsius. That is a reading. The other point that we talk about is a measurement. Now, a measurement essentially, from where we're looking at here, is a culmination of 2 readings. So an example of this would be a change in temperature, and you might observe a change in temperature when you're doing an experiment where you've got the enthalpy change is equal to Q equals mc delta T, and importantly you've got a start temperature and you've got a final temperature. So you do final temperature minus start temperature, and what you end up with is a change in temperature, and this importantly equates to a measurement. And if we are doing that, then we are including 2 errors in our measurement. All right. If we're taking a single reading, like measuring a solution at a given temperature, then we only have the single error from our reading. All right. Now, here we got through that document, they then point out some examples of these 2 instances where we got a reading. So perhaps a thermometer. Now, that's a thermometer if we're taking a single reading, but if we're measuring a change in temperature, as we'll see in a minute, then that might equate to 2 judgments, and we've got a measurement. So just be aware that even taking a thermometer isn't necessarily a single reading if we're doing a change in temperature. The other things that we've then got are things like pH meter, a top pan balance, a measuring cylinder, or a volumetric flask. So if we get any questions associated with things like that where we're taking a reading, our percentage uncertainty is simply the error that we're given divided by the measurement that we take. Now, if however we've got a measurement, all right, so perhaps we've got the change in temperature, which is an example that we'll see in a minute, or with specific example where we're looking at a burette reading, we'll see this as unique in a minute for titrations, then our percentage error, or sorry, our percentage uncertainty becomes an addition of the individual errors. All right, and I'll show you how that works in a minute, divided by whatever that measurement is, multiplied by 100. Okay, so hopefully you're with me so far. The exception to this rule is if we're doing a titration, and this is straight out of, remember, the AQA practical book here, or the practical information, and that is pointing out that if we're taking a measurement from a burette, we've got essentially a measurement for a final reading, we've got a measurement from the start reading, and we've also got an error in the size of the drop, and therefore we've got a total of 3 lots of the error. And this again is key, and this would then be divided by the actual measurement times by 100 in order to get the percentage uncertainty. Now, what has been not so clear is when they've worked through this in the specimen papers, is they've not really identified this, they've just expected this to be knowledge. So the addition to this that we're now seeing from AQA here is where we're dealing with uncertainties in exams, and I think hopefully this will put your minds at ease a bit, is that they've now specified that where there is ambiguity, mark schemes will allow alternative sensible answers and credit clear thinking. All right, so what I'll show you is how this has changed from the specimen into the real exams by doing a few examples now before the end of this brief webinar. Okay, so here we go. Let's have a look at the examples here that I've got for you. We've got 3 clear examples, and the reason I'm really only using these 3, we've not got a huge amount of them, is because we used to have percentage error in the old exam board, but now we're dealing with percentage uncertainty, so there's not really many questions to look back on here. We'll start off here with the specimen paper 1 set 2. So hopefully this should ping up for us. Actually, just before we have a look at this question, I'll just pause and see if we've got any questions so far. Okay, so nothing's come to light so far, and what we'll have a look at is then these examples. So remember, our percentage uncertainty is simply here 10t difficult is equal to the error over the measurement multiplied by 100. I'll just run out of a little bit of room there, so I'll put it here. Now, this question here is talking about some strontium carbonate, and it's going through a thermal decomposition. We've got a series of masses. So this, remember, is a reading. But actually what we end up doing in this experiment is we end up weighing by difference. So this here is a reading, and what we end up working out is a difference in values. And therefore, actually what we're doing in this is we are taking a measurement. So where we've talked about so far, where we've talked about the appearance of the measurement, we're observing here some measurement error rather than a reading error. So when we come through to the question later on, it says each balance reading has an uncertainty of plus or minus 5 milligram. Calculate the percentage error in, and actually this should say the percentage uncertainty. This is a specimen paper, so it won't have gone through lots of iterative revisions in the initial mass of the ore used. So the initial mass of the ore used, we calculate by a difference between 16.11 and 9.85. We've done this in a previous example. So 16.11 minus 9.85 is equal to the mass of the ore. And now, since we've got 2 readings, we actually have, as I said, a measurement, and therefore, in this case, we're going to do 2 times by the value of 5 milligrams. Now notice that 5 milligrams is different to our value here in grams. So as we start to look at this particular example, what we need to be doing is we need to be converting milligrams to grams. So we got 2 times 5 times 10 to the minus 3, and we're doing that because to convert from 5 milligrams 2 grams, we need to divide by 1000 divided by our total value here, which is going to be 16.11. minus 9.85. And if we put that into our calculator, we should find we get a value of hopefully 6. I'm going to check that actually. 16, do that. 16.11 minus 9.885. We get 6.26 times by here our value of 100, and that gives us our error. 5 times 10 to the minus 3 multiplied by 2, and then finally here divided by 6.26 gives us an answer here of 0.160% error. Okay, so that here is where we're observing a measurement from 2 readings. We'll go and have, as I said, this was from a specimen paper. And so what I want to point out is that a little bit, if I would say, ambiguous, and actually what ended up going into the paper 2 for the actual AS paper. So there we were looking at a specimen paper just to see a difference in how they asked the question. Here in the actual exam, and this is presumably after some sort of discussion whereby we had to be a lot clearer, we hear the student said correctly that using a thermometer with an overall uncertainty, the rise in temperature of plus or minus was adequate for this. 2.3. The uncertainty in each of the temperature readings from the thermometer in this experiment was plus or minus 0.25. So we're measuring a change in temperature, okay, and we're told that the error here is plus or minus 0.25 degrees Celsius. Now, what we're then told is this gave an overall uncertainty in the temperature rise of plus or minus 0.5. So the reason that we're being told that is because this is a reading. To get the measurement, we've had to do 2 readings. Measurement, we've had to do 2 readings, and therefore our uncertainty, which we are given in the question, is plus or minus 0.5, and this is then the value that we use to calculate the percentage uncertainty in the experiment. So now, in order to do that for this particular question, what we're going to do is we're going to have percentage uncertainty again is equal to the error over the measurement times by 100. Well, in this case, the error is equal to plus or minus 0.5. So we simply put in 0.5 over the measurement. Now, if we go through and check the measurement, the change in temperature for this particular experiment is over 38 times by 100, giving us a percentage uncertainty in this example of 1.32%. So in the exam, they don't explicitly say it, but they're a lot clearer with which value we need to use. And I'm fairly sure that's as a result of sort of those issues that arose from the specimen paper. The final example then, I just want to show you then, is from one of the specimen papers in the in the A-level exam, which is set 2, paper 3. So these aren't available completely yet, but they will be available on this website before long. The end of this week, I shall be putting them up. Now, in this particular experiment, we're doing that example, or we're looking here at the titration experiment. Now, the key here, remember, is that we said that the error in a reading in our titer was plus or minus 0.05 centimeters cubed, which is half of the smallest scale division, which we see here. And then what we're told in this question is the uncertainty in the mean titer for this experiment. So we're told that the average titer, in other words, the cumulative effect of all of these errors, plus or minus 0.05 that we saw at the beginning, which is 3 times the smallest error. So 3 times 0.05 is equal to 0.15 in this case, gives us, and we're given in the question 0.15, and then calculate the percentage uncertainty in this mean titer. So what we should have done is we've calculated our mean titer from the question earlier on, and hopefully if you'd done that, you should have had a value for the mean titer to be around about 3.98. And so the error then simply becomes 0.15 divided by 3.98 times by 100. And this particular example gave us a value here of 3.77%. Now, the other thing about percentage error, or percentage uncertainty, sorry, is if I come back then, and it sort of alludes to this part here, 2.6, just before we finish, is if we go and look at the key points. Yep, here we go. Percentage uncertainty. We therefore have two ways to reduce the percentage uncertainty. The first way is to reduce the error, so somehow coming with a piece of equipment which is more precise with a smaller scale division. The second way is somehow to increase the measurement. So in respect of something like a titration, if we to increase the concentration, that would lead to an increase often in the tighter volume, and therefore we'd end up increasing the measurement, and we could decrease the percentage uncertainty. Okay, thanks a lot for watching. I will upload the answers to those specimen papers and along with the resources to the past webinar section of the site. So if you're wanting to get hold of the resources to this session, then all you need to go and do, if you've missed for whatever reason a part of the webinar, just go back to the past webinar section, and you'll find that here in the percentage uncertainty once I've updated the site, saying quick practical questions. Tomorrow, sorry, not tomorrow, on Thursday, we'll be looking at the rest of the we'll be looking at the rest of the section of the paper one, which is sort of looking at amount of substance and any other bits that we've not checked off so far. If you're not already a subscriber, do subscribe, and you'll at least get the information about the webinars. And if you want to join, you'll obviously get access to all the previous resources. Thanks a lot for watching, and hopefully I will see you soon. Take care and bye for now.